Hi viewers, hope you're fine. It's me Zafar and you're watching Chemscope. Thank you for joining. Our today's topic is beta-elimination reaction. As we have already taught this lesson about beta-elimination when we prepared alkenes, that this is also named as dehydrohalogenation reaction. Basically, in this reaction we remove HX molecule from an alkyl halide, H from beta carbon, so it's named as beta elimination because beta hydrogen is essential for this reaction, so it is named as beta elimination reaction. Removal of HX molecule from an alkyl halide molecule is called elimination reaction. As beta hydrogen is essential for this reaction, so it is called beta elimination. It is also known as dehydrohalogenation. First of all, we must know what is alpha carbon and what is beta carbon. The carbon that contains this functional group, that is bromide, is alpha carbon, and its neighboring carbon is known as beta carbon, and all the hydrogens on this carbon that is named as beta carbon are called beta hydrogens. In fact, nucleophile or base attacks this electrophilic carbon or acidic carbon. This one is more reactive carbon, and attack happens at this carbon. As a result, we get H and B are removed, and this is called beta elimination reaction. Our result is an alkene. First of all, we know this is highly electronegative atom. It pulls the electronic out of this carbon. Consequently, it becomes partially positive, and this effect is shifted to the next carbon, and this carbon becomes partially positive. That pulls the electronic out of this hydrogen, and this hydrogen, all these hydrogens get partially positive or more reactive. Now we come to the mechanism, how this mechanism takes place. We must know this KOH, and alcoholic KOH is responsible for this beta elimination. Attack can also happen at this carbon, at alpha carbon. OH can attack here, but there is static hindrance. You may ask why it doesn't attack this carbon. This is a weak nucleophile as compared to OH, but it offers static hindrance. As a result, attack of OH at this carbon becomes difficult or often impossible. In fact, this one is our halogen atom. This is partially negative, and this carbon becomes, as a result, partially positive, and this partially positive is shifted to this carbon. As a result, all these carbons get partially positive, and these are attacked by this base. This is heavy base. When you dissolve KOH in alcohol, this OH becomes a heavy base. Instead of asking it as nucleophile, we will call it as a nucleophile. This is very heavy, a heavy base. This attacks on this hydrogen and removes this hydrogen, and the electron of this hydrogen are shifted between this alpha and beta carbon. We get 5 bonds on this carbon. As a result, bromine is removed from this carbon. We know base has removed this hydrogen, and now bromine has to go as a result of 5 bonds here. This bromine is removed, and it goes with this KOH, as we are using KOH, and we get KBr, and OH takes this proton and makes water. This is called our beta elimination because this one is our alpha carbon and this one is our beta carbon, and hydrogen is being removed from beta carbon, so it is known as beta elimination reaction. We know we have removed HBr, H from beta carbon and Br from alpha carbon. This is called beta. This is why it's called elimination reaction. Likewise, we can also quote another example. In this example, you will see this base attacks these these beta hydrogens. This is our alpha carbon and this is our beta carbon. All these hydrogens get more partially positive As a result, base attacks on this hydrogen. Base becomes very bulky as a result of alcohol. Alcohol makes it very bulky. A bulky man asks his food to be provided him. It attacks on this hydrogen by sitting here and takes its food that is positive. And this hydrogen is removed and its electron are shifted between alpha beta carbon and bromine is removed from here. We get an alkene again and get BH. Base removes this hydrogen as BH and bromine is leaving a group here, you can say, to some extent. And this is how beta elimination takes place. We must know two sigma bonds are broken in this reaction. This one and this one. Two sigma bonds are broken and we get a pi bond. And pi bond is our resultant product, contains a pi bond as is breakage of two sigma bonds. Another example of your beta elimination is 2-chlorobutane. It's an alkyl halide. It's a secondary alkyl halide. You must know this one is our alpha carbon and this one is our beta carbon. We have two beta carbons. Now what should happen? Which should be the product? Either H and Cl should be removed and we should get 2-butene, or H from this carbon, this beta carbon, and Cl from here is removed and we get 1-butene. You must know if we remove H from here, its cation is very, you can say its hyperconjugation, or you can say its conjugated structures are much more as compared to when we remove proton from this carbon. So this 2-butene is much more stable alkene. Its product is about 80%. It's our major product and 1-butene is our minor product. This is followed by saytzef rule. This we will study in higher classes. I hope so. You must have liked this video. Thank you for watching. Bye.